Myself, Venkata Swamy, working as a associate professor and additional control of examinations in Marri Laxman Reddy Institute of Technology and Management. As a part of Engineering Chemistry Unit 3 module, and next topic, today we are going to discussing, that is preparation, properties and applications of PVC, Teflon. So preparation, what is the topic we are going to discussing today? So preparation, properties and some of the engineering applications of PVC. That's a polyvinyl chloride. The second one, Teflon, polytetrafluoroethylene, which is called as Teflon, and some of the concept of FRP, that's a fiber reinforced plastics. Fiber reinforced plastics. So this is the topic today we are going to discussing. The first one, preparation, properties and applications of PVC. So here PVC is nothing but polyvinyl chlorides. Polyvinyl chlorides. So polyvinyl chloride, it is called as polymer. So polyvinyl chloride is nothing but polymer, and that polymer we have to prepare. So before that, in the previous classes, we have already discussed about the different types of polymerizations. So among this polyvinyl chloride polymer, we can prepare or we can synthesize it by addition polymerization. Because of vinyl chloride, when we observe this vinyl chloride structure, it's consisting of unsaturation, that is double bond. That is double bond. So unsaturated chemical compounds are nothing but the compound which are containing double bond or else triple bonded compounds, or else alternative double bond compounds are called as unsaturated chemical compounds. And these type of unsaturated chemical compounds are involved in addition polymerization, and it will leads to the formation of polymer. So that type of polymerization we are calling as here addition polymerization. So my dear students, the first point is the polyvinyl chloride, the polymer, we can prepare by the addition polymerization because of vinyl chloride. What is it, Anna? Vinyl chloride. So polyvinyl chloride is polymer. But what is monomer here? Vinyl chlorides. So this vinyl chloride is consisting of unsaturation. So now this one is called as monomer. And this is the PVC, polyvinyl chloride, we are calling as this one is polymer. So polyvinyl chloride polymer, we can prepare by the which type of monomer? That's a vinyl chloride. So vinyl chloride is the monomer and the polyvinyl chloride is the polymers. Next point. And here comes to this properties of polyvinyl chlorides. So usually the polymer which are prepared from the addition polymerization, it is a straight chain polymer, or we can call as a linear chain macromolecules. That's why here polyvinyl chloride is also, it is a linear polymer and which is thermoplastic in nature. So polyvinyl chloride, it's a linear chain molecule because of many monomers. So many vinyl chloride monomers are there combined together in the presence of temperature, in the presence of pressure, in the presence of catalyst, And finally, it will lead to the formation of a polyvinyl chloride is a polymer. And this polyvinyl chloride is a polymer which is a straight chain polymer. It's a linear chain polymer. And at the same time, and it is having thermoplastic in nature, because of we have already discussed in the previous classes. That's a thermoplastic materials and thermosetting materials. Usually, the thermoplastics is nothing but the plastic materials which can be softened on heating and hardened on cooling. And such type of materials we can call as thermoplastic materials. And these are the thermoplastic resins or thermoplastic materials we can synthesize by addition polymerization. In the similar manner, here polyvinyl chloride is also we can prepare by the addition polymerization. Thermoplastic resins are also we can prepare by addition polymerization. That is the reason here polyvinyl chloride is a very soft. It's a very weak and very less brittle in nature. That's why, so polyvinyl chloride polymer which is having thermoplastic in nature. Second point, it's a white brittle solid and hard and rigid material which tends to stick to the metallic surfaces. Third point, it is insoluble in all hydrocarbon solvents. It is insoluble in all organic solvents. Fourth point, it is having some melting point is 212 degrees centigrades and the glass transition temperature is 80 degrees centigrades. So first one, melting point is 212 degrees centigrades and the glass transition temperature is 80 degree centigrade. So these are the some of the important properties of polyvinyl chlorides. Next one, applications of polyvinyl chlorides. Applications. So majorly, and this polyvinyl chloride mostly used in raincoats, for the manufacturing of raincoats and the manufacturing of handbags, the manufacturing of the shower curtains and vinyl floorings and water pipes. Generally, we can call as PVC pipes. So in the manufacturing of in the pipes industries, this polyvinyl chloride, so we can use. And the second important application is this polyvinyl chloride mostly commonly used as an insulation on electrical wires. In the manufacturing of electrical wires, so this polyvinyl chloride we use it as a insulators. So these are some of the important applications of polyvinyl chlorides. So second polymer is Teflon. Second polymer is Teflon, and we will see preparation and the properties and applications of Teflon. Generally, Teflon, another name for the Teflon is polytetrafluoroethylene. Polytetrafluoroethylene is called as Teflon. So the trade name for this Teflon is polytetrafluoroethylene. So that you can understand easily, polytetrafluoroethylene is polymer and here tetrafluoroethylene is monomer. Tetrafluoroethylene is monomer. So my dear students, for the preparation of Teflon, so what is the monomer we are using? That is tetrafluoroethylene. Tetrafluoro. What is the meaning of tetra? Tetra means 4. Fluoro. Tetrafluoro means fluorine atoms. Ethylene, that is nothing but double bonded. So tetrafluoroethylene, usually you know ethylene molecule, that is CH2 double bond CH2. This is ethylene molecule. So when we substitute the fluorine atoms in the presence of hydrogen, so you will get so CF2 double bond CF2, that is tetrafluoroethylene. It is a starting material or it is a monomer for the preparation of Teflon, that is polytetrafluoroethylene. So that my dear students, Teflon, which is called as, the trade name for the Teflon is polytetrafluoroethylene. And here tetrafluoroethylene is a starting material, or it is a monomer for the preparation of Teflon, that is polytetrafluoroethylene. Right. So here tetrafluoroethylene, that is CF2 double bond CF2, tetrafluoroethylene, like I say ethylene. It is also consisting of double bonded group. Ethylene is also consisting of double bonded group, and we can call it as unsaturated chemical compounds. So these type of unsaturated chemical compounds undergoes addition polymerization in the presence of temperature, in the presence of pressure, in the presence of a catalyst. So this tetrafluoroethylene, the monomer, it will leads to the formation of, what is that? Polytetrafluoroethylene, that is Teflon. Now here, first point, Teflon is polytetrafluoroethylene, and the monomer used in the preparation of Teflon is tetrafluoroethylene, that is CF2 double bond CF2, and which is a gas when the room temperature. And tetrafluoroethylene is a polymerized by using free radical initiators such as hydrogen peroxides or benzoyl peroxides or ammonium persulfates at high pressure. So what are the conditions we should maintain here for the preparation of temperature? So we should maintain the temperature is normal room temperature and the pressure is very high. So in the presence of normal room temperature, in the presence of high pressure, so many tetrafluoroethylene monomers they are polymerized in the presence of room temperature, in the presence of high pressure, and it will lead to the formation of, what is that? Teflon. And this Teflon we can prepare by the free radical chain polymerization. We can prepare by free radical chain polymerization. That is the reason, so we are using here initiators. Initiators is nothing but it will initiate the reaction, and this the mechanism of free radical chain polymerization we have already discussed in the previous class. You can see the last video so that you can easily understand. So that here tetrafluoroethylene in the presence of acetyl peroxides as a initiators, and finally it will lead to the formation of Teflon. So Teflon we can prepare from the tetrafluoroethylene. It acts as a monomer in the presence of initiators, in the presence of room temperature, in the presence of high pressure. So many tetrafluoroethylene monomers will combine with each other, and they got polymerized, and it will form a macromolecule, a large molecular weight of substance that will be called as Teflon. That's all. And let's see properties. So comes to these properties. So Teflon is also known as fluon. That is due to the presence of highly electronegativity of fluorine atoms. So usually Teflon CF2 taken n times. This is the structure of Teflon. Usually when we see a complete structure of Teflon, it is consisting of, see, fluorine atoms, fluorine, carbon, and fluorine, carbon, fluorine, fluorine, carbon, fluorine, and fluorine. So many, what does this say? So many fluorine atoms under the Teflon, which is consisting of so many highly electronegativity atoms. So due to the presence of high electronegativity atoms, so what is the concept of electronegativity? So electronegativity is nothing but it will attract the electrons towards itself, and the capacity is more. And the capacity of attracting of electrons towards itself. That's why, so fluorine, it is having some more power, some more, more capacity to attract the electrons towards itself. So that is the reason, due to the presence of highly electronegativity atom, so this Teflon has got high melting points. What is that? High melting point, that is 350 degree centigrades. Due to the presence of highly electronegativity atom, that is fluorine, due to the presence of highly electronegativity fluorine atoms in Teflon, so the Teflon, it will get the high melting point, that is 350 degrees centigrades. Third point, due to the strong attractive forces is responsible because of the fluorine, due to the presence of fluorine, the highly electronegativity atom, so the strong attractive forces are present, and which is responsible for high toughness. It is very strong, it's a very rich, and there is highly chemical resistance towards all chemicals except odd alkali metals. That is, due to the presence of highly electronegativity atom in Teflon, the Teflon has got a high melting point, that is 350 degrees centigrades. The second most important property is, due to the strong attractive forces present in carbon and fluorine, it is having high toughness and it does not react with any chemical compounds. It's a very strong polymer, it's a very toughness and high chemical resistance. It does not react with any chemical compounds except alkali metals. That is first A group elements and second A group elements like lithium, sodium, potassium, like this, first A group elements. Fourth point, Teflon having high density, that is 2.1 to 2.3 grams per cc. And it's a very good insulator. It acts as a very good electrical insulator and it possesses a very good abrasive resistance. So my dear students, so these are the important properties of Teflon. That is because of only due to the presence of highly electronegativity atom, there will be a strong attractive forces in between the carbon and fluorine. That's why they are the important properties of Teflons. Next one, applications of Teflon. Uses of Teflon. So it is used in making of seals and gaskets, and which have the withstands at a high temperature. It will restrict it to the, it will retain with at high temperature ranges. It is also used for insulation for electrical items, for making a non-sticky surface coatings, like examples for the pans, and particularly for cooking utensils. And Teflon used as an insulating material for motors and transformers and the cables and wires and the fitting, etc. So these are some of the engineering applications, some of the important applications of various industrial sites. So this is the concept of preparation and the properties and applications of polyvinyl chloride, and next one is Teflon. The next topic here, fiber reinforced plastics, that we can call as FRP. So FRP stands for fiber reinforcing plastics. So before we are going to discussing about this FRP, first of all you need to understand what is meant by fiber, what is meant by reinforcing, and what is the plastics. So these are plastics already we have discussed in the last class. And now here see fibers. For small objective plastic materials are resistance enough. For bigger objective plastics are very too weak. So we can use plastics for a big objects if we increase their resistance. And in the case if you use this, if you can use the plastic materials for big objects, definitely we should increase the resistance of the particular plastic materials. But how can we increase the resistance of the particular plastic materials? So that we should add, that is, a fiber to the plastic materials. The best process, the best way to increase the resistance of the plastic materials that we should add, that is fibers. So reinforcing is nothing but mixing or combining a plastic materials with high strength fiber materials. You're mixing a plastic matrix with high strength fiber materials so that it results in the formation of a fiber reinforced plastics. So fiber is nothing but high strength materials that you are combining, that you are reinforcing with plastic materials so that it results in the formation of FRP, that is fiber reinforced plastic materials. So usually this fiber reinforced plastics, which are consisting of two components. One is the fiber, one is the plastic matrix. FRP, which are consisting of, one is the fiber material, one is the plastic matrix. See, what are the meaning of fibers? So fibers are used to, it will increase the strength to the thermoplastic compounds. That is nothing but plastic materials. There are the three main types of fibers. One is the carbon fibers, glass fibers, and aramide fibers. And they have some different properties. All fibers have generally high stress capacity than the ordinary steels. We see here glass fibers and carbon fibers and here aramide fibers. These are the different fibers, materials you should mix, or we can reinforcing with the plastic materials or plastic matrix so that you will get a fiber reinforced plastics. So matrix. So the plastic materials used in FRP is called as matrix. So matrix is a tough and relatively weak plastic that is reinforced by a strong fibers. Generally, thermosetting plastics are used as a matrix. That's plastic, but you can use thermoplastic resins or you can use thermosetting. But most in the case, we can use thermosetting plastics are most widely used as a matrix, plastic matrix. So vinyl estates and epoxy resins are mostly common used matrix materials. Thermosetting resins, epoxy and vinyl estates, polyester or phenol formaldehyde resins. That's a Novolac resin and bakelite resins. A best example for this phenol formaldehyde resins. These are some of the important concept of this matrix. The first example is a glass fiber reinforced plastics. So glass fiber reinforced polymer, which is composites, employ a glass fibers for improving the characteristics properties of especially polymeric matrices containing nylons. Already we have discussed in the last classes. That's a nylon 6 and the nylon 6,6. These are two belongs to polyamides, the most used in textile industries for making cloths, polyesters as well as. And this composite possesses lower densities, higher tensile strength, and impact resistance and resistant to the corrosion and chemicals. And applications are nothing but we can use in automobile parts and the storage tanks and the transportation industries and the plastic pipes, etc. So these are the important concept of this glass fiber reinforced plastics. Similarly, a carbon fiber reinforced plastics. Carbon fiber, carbon. So reinforced polymer composites are employed in situations requiring excellent resistance to the corrosion. Resistance to the corrosion, and it does not form any rust on the surface of the materials. A lighter density retention of properties even at high temperatures. A carbon fiber reinforced composites are very strong and often stronger than steel, but lighter, and they are used for making parts of aeroplanes and the space shuttles and tennis rackets and golf clubs and waving machines and missiles and agriculture purpose, etc. So these are the important properties of the carbon fiber reinforced plastics. A third one is aramide fiber reinforced plastics. For example, that is a bulletproof plastic material, the best important application for the fiber reinforced plastics because it's a very strong. So aramide is a short form of aromatic polyamides. So already polyamides we have discussed, that is nylon 6 and nylon 6,6. mostly used in textile industry for making cloths. In a similar manner, here aramid is also it is a aromatic polyamides. The best example for the aramides is Nomex and Kevlar structures, and these are used to make bulletproof vests and bicycle cycle tights. And this is the bulletproof jackets. So these are the important properties and applications of this aramide fiber reinforced plastic materials. Yes. So this is the concept of what is that? FRP, fiber reinforced plastics, and what are the example for the fibers reinforced plastics and its applications. Thank you, and thank you so much. And next class we will see here rubber topic. Next class we will discuss. And thank you so much.